Number 24 is probably a good one to do together because we don't have the actual individual data values. They're already clumped into a histogram. The main idea is that we're going to use those midpoints to make estimates. So this histogram displays hours of sleep per day for a random sample of 200 subjects, and we're going to estimate the mean, standard deviation, and coefficient of variation. Let's start with the mean. So there is a fancy formula for this, but the basic idea is that you're going to pretend that you just have two data values of 3.5, two data values of 4.5, four data values of 5.5, 22 6.5s. And so we know that those probably aren't the actual data values, but since it's an estimate, that's the best we can do. So we're going to take two 3.5s. We're going to add all these together. I got a total of 1,580. And so pretending that each value in the histogram was a midpoint value, that would have been the total of all the values. And how many values were there? They say there were 200 subjects added together. So this is 200 people's hours of sleep all added together. So if I wanted to find the mean, I would take that number divided by what? The total divided by how many people? And we get a mean of 7.9 hours. Remember that that's an estimated mean using the midpoints. Let's work on the sample standard deviation. So this time I really wouldn't want to make a table because the table would be 200 rows long. There would be a lot of repeats, like that 8.5 would repeat 90 times, but still I think the computation formula might be our advantage this time. So there's kind of this weirder looking one that goes with histograms or frequency distributions, but let's stick to the one that we learned in the lesson. And the two things I like to figure out on the front end are the sum of x squared and the sum of x. And we already found the sum of x, right, when we were finding our mean. That was 1,580. And this time we want to find the sum of all the x squareds. So we would want to think, okay, I've got a 3.5 squared twice, and a 4.5 squared twice, a 5.5 squared 4 times, and so that might look something like this. So that's a lot, but I got 12,702 for my sum there. So we're going to use those two numbers and just plug them into our standard deviation formula. You want to carefully type that into your calculator, and what that comes out to is 1.05. And the label on that would be hours, standard deviation. And for coefficient of variation, really no modifications we need to do because it was a histogram. We're just going to take our sample standard deviation divided by the sample mean times 100 to make it a pretty percent. And I'm getting a coefficient of variation of 13.29%.